carrying on with polynomials, now we're going to talk about end behavior. And then we want to think, wait, what's end behavior? I mean, I know what behavior is. I know my mom has definitely told me sometimes I have bad behavior, but, you know, what does she know, right? And is this like how I'm going to behave at my end? Because I'll tell you, it's not going to be pretty. But that's not what we're talking about here. We're talking about polynomials. Sorry, I digress. Anyway, end behavior of a polynomial. So we want to think about as the graph is going to its ends, so left and right, that's what we mean by the ends. What is it doing? Is it going up or is it going down? It's a great question. All right, let's look at some graphs. So here, first thing I want you to do is just look at each one of these graphs. These are the graphs of the equation you see above. And I want you to identify the degree and the leading coefficient of each of them. So just pause the video. You should be able to identify the degree and the leading coefficient. Unpause when you are ready to discuss that. All right, so hopefully we know this is a quadratic, so this is degree 2. The leading coefficient is just a 1, right? If nothing's written there, I know that there's a 1 there. This is degree 4, leading coefficient -1. Degree 3, leading coefficient +1 again. Degree 5, leading coefficient -1. Excellent. Any questions on that? No. Good. Moving on. Perfect. So, end behavior, right? And I said that this has to do with as the graph goes to the left and as the graph goes to the right. So, as this graph is going to the left here, is it going up or is it going down? I'll give you a hint. The arrow that I drew is kind of showing you what it's doing. So, this is going to the up. It's going up as we go to the left, right? Correct? Sorry. And then as it goes to the right, it's also going up. So left, up, right, up. We could also say up left, up right. Questions on that? Okay. So now I want you to pause the video again, and I want you to identify the end behavior for the other 3 graphs. Pause the video. See if you can do that. You can just use the arrows if you want, or the description. I'll accept either one right now. We'll talk about how to formally say this in a minute. Pause the video. Identify the end behavior. All right, so hopefully we recognize here it's going down left, down right, down, down. Here it's going down left, up right, down, up. Here it's going up left, down right, up, down. Notice that we are writing these, if we're using the arrows, in the order, right? So the left should always come before the right because we read things from left to right. That will avoid any confusion. And if we use the words, then, well, it's the words. They should hopefully be self-explanatory. Okay, so now we want to see, do we recognize there's a pattern that has to do with the degree and the leading coefficient. And so notice that all of these have a different degree, and these two have a +1 as the leading coefficient, and these two have a -1 as the leading coefficient. So I want you to take a second and see if you can identify, and use your calculator or Desmos if you want to help you with this. See if you can figure out what is the pattern. How is the degree and the leading coefficient controlling the end behavior? Because they are. So maybe try a few other examples with different combinations of the degree and the leading coefficient. And see if you can figure it out. Pause the video. Unpause when you're ready to check. All right, so the pattern is that if the degree is even, or if it's odd, and the leading coefficient is positive or negative, that is going to control the end behavior. So if the degree is even, and the leading coefficient is positive, then the end behavior is going to be up, up. And we see that here. Degree is even, leading coefficient is positive. If the degree is even, but the leading coefficient is negative, then the end behavior will be down, down. And we see that here. Degree is even, leading coefficient is negative, down, down. If the degree is odd, and the leading coefficient is positive, then the end behavior is going to be down left, up right. We see that here. Odd degree, positive leading coefficient. And if the degree is odd and the leading coefficient is negative, then it is going to be up to the left and down to the right. And we see that here. And now then it's really important that we understand it doesn't matter what the degree is, it just matters if it's even or odd, right? So it doesn't matter that this is 4, it could be 6, it could be 8, it could be 10, it could be 1012. As long as this is even and this is negative, this will be the end behavior. And same with the leading coefficients. All of these had a value of 1 or negative 1, but it wasn't the value that mattered. It was just whether it was positive or negative. So this could be, again, negative 1 billion, and if this is degree 4, the end behavior is down left, down right. Now, the last thing I want to look at on this slide is this right here. You might be looking, whoa, what is that? We haven't been talking about this at all, negative infinities and infinities. We actually have. This is our formal notation that we're going to use for end behavior, and so we want to make sure we understand it. So when we see, and let's use highlighter because it's fun. When we see this, that is saying as x goes to negative infinity, which is saying as x goes to the left. So this right here is saying, well, actually, I'm not going to say to the left. I'm just going to say left. So this is our left. The other one, this is saying as x goes to positive infinity. So this is going to be to the right. And then our answers are, what are the y values doing? And remember, f of x is the same thing as y. And that's what we're actually doing here. When we're saying up or down, we're describing the change in the y coordinates. So here, the y coordinates are continuing to decrease, right? Here, the y coordinates are continuing to increase. Increasing and decreasing are things we've talked about before. So as x goes to the left, that's how I read this, y does what? And if it's going up, then we would just write infinity, positive infinity. And if it's going down, we would write negative infinity. So for example, let's take this one here, where our answer was up, down. So my answer here would be infinity, and then negative infinity. Okay, so just so we're clear, this is my answer to this end behavior. Okay, this is just the formal notation in which I would write this. Here, since this is down, up, I would have written negative infinity, infinity. Since this is down, down, here, I would write negative infinity, negative infinity. So the thing I want to point out is this part here that I had typed out, that will not change. The only thing you're writing is just infinity or negative infinity to represent up or down. So infinity is the same as up, negative infinity is the same as down. All right, hopefully that makes sense. I've been rambling on about it a lot. Next thing, here, given this function, identify the end behavior. Pause the video, unpause when you're ready to check. So here, I recognize the degree was even, leading coefficient's negative, so as x goes to negative infinity, f of x is going to go to negative infinity. As x goes to positive infinity, f of x is still going to go to negative infinity. This end behavior would be down, down. Next one, or ones, 3, there's 3 of them. So here, I want you to try all 3. All you're doing in the first part is exactly what you need to do to identify the end behavior anyway. So identify the degree, the leading coefficient, and then the end behavior for each of these. Pause the video. Unpause when you're ready to check. My hint, read carefully. Go ahead and pause. Try. You got this. I believe in you. All right, so hopefully for the first one here, we recognize the degree is 3. The leading coefficient is 3.5. What we care about is that it's positive. So as x goes to negative infinity, f of x is also going to go to negative infinity. And as x goes to positive infinity, f of x is going to go to positive infinity. What this means in terms of arrows, this is down left, up right. For h of x, degree is 4, leading coefficient is negative 5. Key thing is that it's negative. So as x goes to negative infinity, h of x goes to negative infinity. As x goes to positive infinity, h of x still goes to negative infinity. So this end behavior we would describe as down, down. And then g of x, this was the tricky one maybe. We want to recognize the degree is 7, and the leading coefficient is negative 2. So this polynomial is not written in standard form, and we still need to make sure we identify what is the accurate degree, and then the leading coefficient is the number in front of that term. So the degree is odd, leading coefficient's negative, so we're going to go up left, down right, or as x goes to negative infinity, g of x goes to positive infinity. As x goes to positive infinity, g of x goes to negative infinity. All right, so this little chart is handy in understanding our end behavior. Hopefully, the more you go through it, the easier it is to understand, and you just kind of know it. Keep in mind, another hint that I like to tell people, and this is kind of, how I think about it as well, is think about like the most basic even degree polynomial so like a quadratic, x squared, and with a positive leading coefficient, what does it look like, right? And that pattern is going to be the same for everything with an even degree and a positive leading coefficient, and the same for the rest of these as well. So an odd degree polynomial would be just like a line, so like y equals x. And what does that look like? If it's y equals x and it has a positive leading coefficient, it's down, left, up, right. And if it was y equals negative x, then it would be up, left, down, right. And then the last thing is really making sure we understand this notation, because this is how we're going to see answers and need to write our answers. So understanding this notation is going to be important, and how the arrows translate to this notation. And our answers here are always just infinity or negative infinity.